Sabi Africa. No Africa. No Africans. Pioneering role in science, engineering, and technology.
Sabi African Network, illuminating Africa's narrative as pioneers in science, engineering, and technology.
Traditional methods of leather tanning and their environmental impacts. Across Africa, communities have been turning animal hides into long-lasting leather for centuries, using plant extracts, ash, smoke, and oils. These are not just old methods, they are smart biochemical techniques built from deep observation of nature. And today they offer clues for building cleaner, more ethical tanning industries worldwide. Tanning is the process that stops a hide from decaying. At the molecular level, it stabilizes the collagen network so it resists heat, microbes, and moisture. Traditional African methods from alkaline ash soaking to plant-based tanning work by reshaping the chemistry of collagen using natural polyphenols, minerals, and lipids. Before tanning, artisans soften and clean the hide. Wood ash, rich in potassium carbonates and hydroxides, creates a mild alkaline bath that loosens hair and opens collagen fibers. This simple material acts like a natural biochemical switch, preparing the hide without relying on heavy industrial chemicals. Many African tanneries use bark and pods from acacia or cassia trees. These materials are full of tannins, complex polyphenols that bind tightly to collagen. Once inside the fiber network, tannins push out water, strengthen the matrix, and give the leather its signature warm tones. The process is slow, but the result is strong, flexible, and almost entirely biodegradable. In some regions, hides are smoked over slow fires. The smoke deposits phenols that add color and microbial resistance. Others use emulsified fats from brain or egg mixtures to lubricate fibers. These methods show a deep understanding of how natural oils and smoke particles interact with collagen to produce softness and water resistance. Traditional tanning relies on locally sourced, renewable materials. It avoids heavy metals, synthetic dyes, and high-salt wastewater. When properly managed, the waste from plant tanning can be returned to soils or composted. In an era of growing concern about chemical pollution, these indigenous methods present real ecological advantages. Modern chrome tanning transformed the leather industry because it is fast and predictable. But when tanneries discharge untreated wastewater, chromium and sulfides contaminate rivers and farmland. Without strict process control, chromium can shift into more toxic forms. This creates long-term health risks for workers and surrounding communities. In iconic tanning hubs from Kano to Morocco's ancient Medinas, small workshops have had to adapt as populations grow and water systems become strained. The problem is not traditional craft, it is scale without infrastructure. Strengthening these clusters with modern drum designs, water-saving flows, and shared treatment plants can preserve both livelihoods and ecosystems. Researchers across Africa are refining traditional methods with scientific tools, standardized tannin extracts, hybrid vegetable metal processes, and low-water techniques that reduce pollution while maintaining leather quality. These innovations prove that indigenous knowledge is not just cultural heritage, it is a foundation for cleaner industrial futures. The world is searching for sustainable materials and fair production systems. Africa's traditional tanning heritage offers both. By elevating botanical tanning, improving infrastructure, and valuing craftsmanship, the continent can lead a new chapter in ethical leather production. This is more than industry. It is cultural memory, ecological intelligence, and technological creativity fused into one story.